Okay, we have some questions for Math 110, and these are some questions from, I think, Chapter 2.1, Section 2.1. I'll go ahead and pull up the whiteboard, and we'll look at them. And I think there's about 4 of them. Let me get everything going, and hopefully I can, well, I'm trying. There we go. Okay, now I can do it. Pull up the homework, or pull up the questions. All right, the first question is, because I've already done that question, so I think, I don't know, let me see, it's 2.1, yeah, we did that one. This one is 2.141/10. 2.141/10. That's like number 41 in the book, number 10 online. And this question, well, I'm waiting for it to come up. Okay, visual observation. So it says, use visual observation to determine whether the graph is symmetric with respect to the x-axis, b-axis, or the origin. Okay, so let's first of all look at the origin. The origin is what it's asking for. So what you want to do is just draw a dot right here. Say, okay, there's the origin. Now, if it's symmetrical around the x and y axis, you're going to see the same thing. All right? If it's symmetrical around the origin, you're going to see the same thing across the origin. Now, I know you say to yourself, that's, well, let me just say it this way. If this is the y-axis, and you have, and this is your, let's say this is your face. Okay, I am not an artist. Okay, there's your face, your eyeball, okay, and your forehead and all that. Okay, this side would look the same, and I cannot draw, so there. So that's symmetric around the y-axis. If it's symmetric around the x-axis, it would look like this. And I'm just going to imagine that there's a y-axis right here so I can draw my picture. And the picture, if you look at this mirror, and that's you, it's like a bird, then it is symmetrical around the it would be symmetric around this way. Okay. Now across the origin, it would be symmetric across the origin like this. That's the nose. I'm getting tired of drawing. Okay? And then it would be, your chin would be right here, and it would be like that, and then this, and then that. I'm sorry. The nose would be like that, and then like that. And the reflection, think of it as a mirror, and think of it as a reflection. The reflection is here. The reflection is here. The reflection is here. So this would be reflection around the y-axis. This would be reflection around the x-axis. And this would be reflection around the origin. So let's just take, for example, these two pieces right here. They are reflective around the origin. Okay? If they were reflected around the y-axis, this is what it would look like. I mean, the x-axis, that's what it would look like if it was reflected around the x-axis. If it was reflected around the y-axis, it would look like this. Okay, so you got to think of it. What does the mirror image, where is it reflected from and where is it going? All right, so either you've got a reflection this way you've got a reflection this way, or you've got a reflection diagonally. And diagonally means around the origin. Okay? And that's how you do the reflection questions. Now, let's go ahead and let's see what is up with the next type question. The next question is, that's 2.141. This is 2.1. Okay, that was 21. What was this one? Okay, we're going backwards for some reason. All right, this is 2.121/5. 2.121/5. Okay. All right, board, help me out here. Okay, for some reason, there we go. Okay, determine the largest open intervals of the domain over the functions shown in the graph, increasing, decreasing, and constant. Well, I'm going to go to the whiteboard here because I go through and teach this. Let's say you've got a big graph up here. And let's say that the graph looks like this. Everybody with me? And let's say that this is, of course, we know this is negative infinity. And it's got an arrow, so that's going negative infinity. This one's positive infinity. This one is positive infinity in the y direction, and this is negative infinity in the y direction. And let's say that this point right here, the bottom, the vertex of this function is at 1. Okay? So we're going to talk about this function, and all we're looking at is just the graph. So, first of all, let's talk about the domain. The domain. The domain is our input. In other words, this function, if it was the function x squared plus 4 or whatever, we don't have the function because it's a graphic representation, so we don't have the function like f of x is equal to 2x plus 4. So what we look at is these numbers right here. I'm going to take my highlighter. What numbers can we use for this function? Well, what do these two things right here mean? Well, it's supposed to be one right there, but let me put one right there. If you're given a function and it has arrows like this, and there is no restriction on which direction it's going, like this one just keeps on going. That arrowhead right there means that it just keeps on going. And this arrowhead over here means that it what? Keeps on going. So therefore, the domain, when you have arrowheads, the domain is all real numbers. Okay? What is the range of this function? Well, what is the range? The range is your output. Usually, it's your y. Okay? Where the domain is x values, your range is your y value. So I'm going to take my handy dandy highlighter and take the blue, and I'm going to highlight this area because our function is right here, and we're going to see all these. This dot right here lines up with this. This dot right here lines up with this. So, and these two arrowheads are going in the upward direction. I don't know what that just did. Let me get back here. All right, that needs to be like that. Sorry. All right, and this needs to be in upward direction. So it's good. All right. So all of these values is what we call your range. So from 1 to infinity, 1 to infinity is your answer. Now, I'm not going to go into the interval notation because that's something that everybody should know with their 101 and 102, but I'll just bring it up right quick. The bracket means inclusive. The parentheses means exclusive. So if you need to look that up, just look up interval notation, and your book should tell you review over that. Okay? Increasing and decreasing. And this is where I bring in the airplane, and I try to make it as easy as, okay, my board is giving me problems. There. First of all, there's this thing over here. I don't know why we're having this big green clear all, expand. No. Okay, we'll go away then. That's not going away. Hold on a second. Okay, I don't know what this thing is. It's not even on the screen. Okay, well, I don't know what this is, and I wish it would go away, but I don't think I'm going to be able to get rid of it, so I'm just going to have to work with it. Okay. So let me just go ahead and go over increasing and decreasing. Increasing and decreasing. I always start from left to right because that's what we do. We read from left to right. So I'll draw you a plane. And I take this plane and I look at it from left to right. So I take it and I pull it up here and I say, what's happening from left to right? What's happening to this plane as I start from the left-hand side? What's happening if I follow that line? It's going down, Hubert. That's right. It's going down. So that means decreasing values. So, and the only thing in terms of the y, axis is the range. Everything else is in terms of the x-axis. So it's decreasing from negative infinity to, and this point right here is 1. And this point right here, I'll fix that in a minute. 1, sorry, I messed up. 1. And it's increasing from 1 to infinity. Okay, so let me get that plane. And that plane, when it gets down to 1, as far as the y value, because that's supposed to be 1 and 1, and I didn't put that, but see, it starts going what? It starts going up. So your plane, and this point right here is 1, 2. Oh me, this thing is giving me fits today in both my classes today. This right here is 1 also. So you got a x of 1 and a y of 1 right here. Okay, so the range is from 1 to infinity, and the plane, when you do an increasing and decreasing values, you act like you just mentally take the plane, just mentally, in other words, mentally take this plane and just start from the left-hand side of your page and say, okay, what's this plane doing? And then just angle it towards your line, and that plane is decreasing till it gets to x is equal to 1. And then when it gets to x is equal to 1, it starts doing what? It starts increasing. Some people may write it like this. Remember back in Algebra 1 and Algebra 2, you might have done this. You might have put decreasing. Of course, if you had a pencil that wrote, I don't have a pencil that writes. I have a pencil that writes half the time. Anyway, there. And then what happens to the y values on this side? They increase. All right? You're going downhill, then you're going uphill. So you're decreasing from negative infinity to 1. That's 1 right there. And then you're increasing, this is 1 also. And you're increasing from 1 to infinity. Remember, Your increasing and decreasing values are always in terms of what? X. Your domain is always in terms of what? X. The only thing that's in terms of Y is the range. Okay? The only thing in terms of Y is the range. So with that being said, and I can't go, I wish this thing would go away, it really bothers me. Okay, let me go to the question that we had on the homework. And for those of you that, oh great, now I can't. I can't get to anything because of this. Hold on, please. It's not letting me do anything. Okay, for some reason, it's just not going to let me get rid of it. I don't know what else to do except just try to work with it, and I can't work with it now because I can't get. I don't know. It won't go away. Yeah, it won't go away no matter what I do. Okay, so I can't get out of this because I can't. Y'all can't see, I don't know. Okay, there, it went away. Hallelujah. Okay, I'm sorry about that. So here's our question. And there's not really any way I can make that graph. Yeah, I can. I'll make it a little bit bigger. So I'm going to make this graph a little bit bigger so I can put my plane on it. Well, it's not going to cooperate. There. So I don't care what the question's asking. The only thing I care about is you find the domain, range. So what's my domain? Well, the domain here is going to be broken up because this is what we call a piecewise function. It's in pieces. All right, so this tells us that our domain just keeps on going and going and going like that. All right, so that means negative infinity is down here. That's negative infinity. And since that thing keeps going and going and going, we're going to start our domain with negative infinity because we read from left to right. And then it's going to get to negative 2. And we put a 2 there. Now, since this is a closed circle, it gets a bracket. Go back to your interval notation notes and review over that. And that's it for that function. But then it picks up here at negative 2. Do we touch 2? Right here, this is open circle. No. So we go negative 2 and put a parenthesis on it. And then we go to positive 4. And we put another parenthesis on it because of this open circle. And then we go from 4 with a closed circle to infinity because this is positive infinity right here. And this means it just keeps on going. I'm exaggerating a little bit, but it just keeps on going. So that would be infinity. So your domain for this function is, this piecewise function is as follows. Now, like I say, on a piecewise function, you're dealing with pieces. So you're going to have to think, and you're going to have to read from left to right. Your range. Your range on this function is y-axis, y values. So don't look at the x. All right, so this means negative infinity. This means positive infinity. So you know that the domain is going to end with negative infinity and positive infinity. But I'm going to start from the bottom and I'm going to go up. So that means negative infinity. I'm hitting that first. So negative infinity. Negative infinity and positive infinity always gets a parentheses because you can't touch it. And we get up to what? We get up to, looks like 0.5 or 1/2 negative. Do we touch it? It's got a closed circle, yes. So that means bracket. Is there a function anywhere between here and this? No. So we cannot put from -1 to 1.5. We can't do that because there's no function in here. All right, if you take this area right here, I'm going to highlight it. If you take this area right here, between the blue lines, these right here, between here and here, there's nothing in here. So you can't say that the blue line is continuous because you're looking in terms of the y-axis, which is your y input or xput. I'm sorry. What you get when you plug in x, you get y, your output. So I'm going to start here because I'm thinking in terms of my y-axis. Here is 1.5 and it's got a closed circle. So that's 1.5. Sorry. And it gets a bracket because that bracket right there is telling you that it's inclusive. And this one goes to infinity, but it does not touch -3 because this says you can't use -3. So you have to put a note in here that says 1.5 to infinity, but x cannot equal, or y cannot equal 3. Okay, now you can do that two ways. You can say 1.5 comma 3 and then put a parenthesis and then go from 3 to infinity like that. Okay, that's your range. Now again, how many ranges do you have? Well, there's technically like 2. There's one here and one here. Why? Because you have 2 pieces. You have this piece right here, and then you have this piece right here. Now, as far as the y terms, this is right here. When you see this right here, that's right there. Y cannot equal -3 because of these open circles. If these open circles were closed, like that, then you wouldn't have to use this right here. Okay? Is this a test type question? No, I wouldn't put it on the test because, especially in this introductory review section, because piecewise functions are complicated anyway. But you just have to realize you're going from left to right and you're going down to up with your domain and range. Now let's talk about increasing and decreasing. Again, we have a plane. I hope I can draw this and it don't go crazy. And we take our plane. Eventually we take our plane, if this thing would work, there. And we bring that plane down. See, that's what I was afraid was going to happen. Okay, let me draw a plane over here where it's not touching anything. Oh my gosh. This thing today has not worked well at all. Okay, there's my plane. It looks like a boot, but I really don't know what's going on with this thing. Okay, let's take this boot, which is supposed to be a plane. It's not going to let me do it. It's not letting me do anything, really. Okay, there we go. All right, there's the plane. And what are we doing from left to right? We're decreasing. We're decreasing until it gets to what? Until it gets to -2. until it gets to -2. So it's decreasing. It's decreasing from -infinity to -2. And the first thing somebody's going to say is, what do you mean -2? That's -1.5. All of these things are in terms of x, except for what? Except for y. So you don't even be looking at the y-axis. All right, so you bring it down, and then what happens? Then you are a constant up here, because you're going from left to right. So you take your plane and you move it up to that next line, because when you go left to right, it's like a roller coaster without tracks. You jump off the tracks, you jump right here. And this is a constant, so it doesn't move. It's called constant. So it's constant, and it will probably ask you that. It's constant from -2 to +4. -2 to +4, and you have open circles, so that takes that. And then it's decreasing. Take your plane. Take your plane, and you jump off the track there, and you boom, you jump down here. And now you're decreasing. Now you're decreasing. Okay, I can't, there. You're decreasing from 4 to infinity. So you're decreasing from 4 to infinity. Decreasing from 4, and you have a closed circle, to infinity. Okay? So I know this is kind of a jumble, it's kind of a mess, and the board is not cooperating with me. But the whole thing is that you need to read the domain from left to right on the x-axis. You need to read the range from the y-axis, and you need to read the increasing and decreasing from left to right. Remember, it's a plane. In this plane, it was decreasing. It went, jump the track, constant, jump the track, decreasing. And that should be the questions they ask for this particular problem. They should ask those type questions. Let's see what they ask if the board will cooperate. Let me erase everything now. Is the function, it says the function is in open intervals. Open intervals. Where is open interval? Here is the open interval right here. When I said constant, what the heck? When I said constant, that's open interval right there. Because what do you have on each side? You have open what? Open circles. So this function right here, this part of the function is open. So is it increasing or decreasing? It's never increasing there. It's not increasing. So, okay, it's either increasing or not increasing. All right. Over what open interval, if any, is the function decreasing? Okay, I'm sorry. The function, where is it decreasing? From -infinity to -2, right here. From -infinity to -2, and from 4 to what? 4 to infinity. So that's decreasing here and decreasing here. I'm sorry, I might have had increasing on the previous one, but it was decreasing. And then right here is the open interval that is constant. And I think they'll ask right there, constant. There it is. Then the domain is all real numbers. And then the range is negative to 0.5, and then 1.5 to infinity. And I think we talked about that on the previous problem. I mean, on the sketch that I drew. So let's go to the next question. And the next question is, let me go back. I have to go back and log us off every 5 minutes. I think that was, yeah, this question is 2.1, number 15, number 3. 2.1, number 15, and number 3. I don't know why the computer is putting these in reverse order, but you'll get over it. All right, let me make this a little bit bigger. And, well, I thought I was going to make it bigger. Let me pull it up again and make it bigger here. There we go. All right, now the question here is asking, what is your domain and range? Domain and range, real simple. Just read from left to right for your domain and read from bottom to top for your range. So your domain is your x-axis, is your x values. So these are considered to be arrows if they're not there, so I'm going to go ahead and put them there, and here and there. This is positive infinity. This arrowhead over here is called negative infinity. This arrowhead is called positive infinity. This arrowhead is called negative infinity. And that's always true no matter if you're in Algebra 1, Algebra 2, or whatever. Now, our function is in blue. This arrowhead says that as far as our domain goes, it just keeps on going. All right? So that's negative infinity. So we know that our domain is going to start right there at negative infinity, because if we read from left to right and there's an arrowhead right here, the arrowhead tells us that it just keeps on going. So negative infinity is where we're going. And we get to -7 and we hit this red line. Well, that red line is what's called a vertical asymptote. All right? So that's at -7. And it gets a parenthesis, and this gets a parenthesis because you can't touch them. Okay? And then it picks up at -7 on the other side of -7. It doesn't touch -7. And then it keeps on going to what? Positive infinity. So your domain for this function is negative. And I know you can't see this, and I wish you could, but let's see if I do it this way. Let me do a vertical line. I'm going to make it a little bit thick, and I'm going to make it this blue color. I'm going to draw it right there. Okay? Now I'm going to take it, and this is your eyeball going across from left to right. Okay? Think of this blue line as your... Think of this blue line as your eyeball going from left to right. All right? Start at the page over here. Okay? Okay, here's your eyeball, and it's going, it's going, it's on negative infinity, it's coming, it's coming, it's coming. It goes on, it's on your function, it's on your function, it's on your function. Boom! It hits a wall at where? -7. It jumps the wall. It jumps the wall and starts at -7 on the other side of -7, and it goes to what? It goes to positive infinity. All right, now you can do the same thing with the y-axis in your domain. So we're going to turn this thing this way. That's your eyeball. All right, and we're going to find the y values that is in this function. So that's the range. So we start from the bottom, because I always start from the bottom. So that's going to be negative what? Right there, negative infinity. So I'm going to start down here. Boom, I hit my function right there at negative infinity, but it keeps going because of the arrowhead. And where I get, boom, I stop at y is equal to 0 because I can't cross it. So I jump it. Boop. I jump it, and then I take off and go to what? Positive infinity. So my range, as far as the y values, is from negative infinity to 0, and then I pick up at 0, on the other side of 0, and I go to positive infinity. So that is your range for this function. Okay? And that should help you on that problem. And that's what they're saying right here. The function is not continuous because you have to jump. Okay, that jump means not continuous. And there's negative, there it is right there. Okay, and then that's all they're asking there. Continuous is like a train track. It just keeps on going and keeps on going. Non-continuous is when you're dealing with something that has a gap in it, something that has a break. This has a gap in it because of the red line and the x and the y and the x-axis. okay? Depending on which way your eyeball's going. All right. Okay, that's that problem. And the next problem is 2.3, number 59, number 11. 59 in the book, number 11 online. And it's not cooperating. Golly, what a surprise. There we go. Let's see what this one says. Use the function, use the accompanying graph of y is equal to f of x to sketch the graph of each function. All right, f of x plus 4. Okay, well, before I do anything, I'm going to make a, okay, let me just go here and remember. Now, you may not have gone over this yet or not in your book, but whenever you have a function, let's say, I'll just use what the book uses. F of x is equal to a times x plus h plus k. Okay? This a, and I go through this in the videos, this a is orientation. This h is horizontal shift. Now, for it to be the horizontal shift, it has to be attached to x in some way, form, or fashion with a plus or a minus. When it's plus, it goes to the left. When it's negative, it goes to the right. This is the only time you're going to see this happen, all right, in mathematics. K is your vertical shift. Okay, and if it's 3, it goes 3 up, and negative 3, it goes 3 down. So positive means up, and negative means down. When you have a positive A, that means it's normal. When you have a negative A, that means it's going in the opposite direction of normal. Okay, so a positive would be like this. If you have a function like that, negative would be like this. It's the opposite direction. Okay, so that's a little bit of what you're learning in this section. This function right here tells you you have a vertical shift of 4. Does it change? Does the function change? No, the function does not change. It still looks like this, but it's going up 4. 1, 2, 3, 4. So you need to find where the vertex in your answer is at 4. So let's see. That's not right. That's at negative something. Okay, so it has to be. Let's see. I think I'm in the wrong place on this. Yeah, there we go. I'm sorry. I messed up. Let's leave it right there, and I'll erase this. There we go. And I will mark through what that's a negative. See, that's that origin. This right here is at a negative, so that's wrong. This could be an answer because it looks like it's at 4. This could be an answer because it looks like it's at 4. So we got to look at the orientation. The orientation is up, down, up. It's not this one. Up, down, up. Up, down, up. Okay, that's not right. I'm sorry, when the problem started, I must have not hit the right. If board there, I'm sorry, I was on C. Oh. Like I said, this board has not cooperated at all today. Okay, let me start over. Okay, we got looking for this origin at 4, right here. So find the origin at 4. Where is there you have an origin at 4 with this vertical shift of 4? All right, that's not it. That's negative. That's not it. That's to the left. This is possibility, and this is not it. So it's got to be this one. Okay? Now, the second one. Negative f of x minus 3. So that negative right here tells us that it's going in the opposite direction. So that means it's looking like this. Down, up, down. All right? That's what the negative tells us right here. Negative tells us it's going in the opposite direction. The -3 tells us it's going to be a vertical shift of 3 down. Okay, 3 down. So go over here to your answers. And I will erase these marks that I put up here. I don't want to erase the whole page, just the marks. And I'm going to pull this down. Hopefully, when I answer some more questions, this board will not be giving me fits. So let's find a problem. Let's find an answer where we have a opposite, down, up, down, and a vertical shift of 3 down. Okay, that's 3 up. That's not going to work. That's 3 up. That's not going to work. So it's either this one or this one. Which one goes down, up, down? Down, up, down. So that's your answer. This one goes up, down, up. This is with the word, the original. But the negative f of x, this tells us that it's going opposite direction. Okay? And I cover this in the videos. There's a video that has the family of graphs on it, where I tell students to take a piece of paper and divide it up into 8 sections. And that's where I start the family of graphs. So you might want to look for that function. It should be, look for that video. It should be in here. All right, now the last one. What does this last one do? Good gracious. Well, remember A tells us orientation. It also tells us whether it's skinny. If it's skinny, it's going to be greater than 1. A is greater than 1. If it's wide, it's going to be between 0 and 1. A is going to be between 0 and 1. What does that mean? It means like a fraction. Well, let me erase these. Right quick. I hope this will work. There we go. All right. So let's look at what we got on this section right here. Well, I'll try it again. Mouse, mouse, mouse. I'm going to hit it 3 or 4 times and maybe it'll work. Nope. There is something definitely wrong. Every time I hit it, it does something different. I don't know what it's doing. Okay, whatever it's doing, I can't get it to work. Okay, so we've got 2f. That 2 tells us that it's going to make it skinnier, which is going to make it taller. Okay? And that's a good representation right here, but it's not the right answer because of the half of x. Now that means I'm going to plug in a half of x. Well, what does half of x? If x was 2, what does x become if I take half of 2? It becomes 1. What does 4 become? It becomes 2. So it's going to be probably the next, I wish I could show you what the answer is, but I can't pull it up. Every time I try to pull it up, it won't let me pull it up. I'm sorry. There. I'm not going to touch it because it might blow up. All right, so here we go. It's not this because it makes it wider. It's not this because it makes it smaller. It's this one right here because it makes it taller and it spreads it out also because of the 1/2. See the 1/2? That's the fraction between 0 and 1. So this is your answer here. Now, I know this may seem kind of confusing, but you're going to have to watch the video where I talk about A, H, and K. If you don't watch that video, you're probably going to be a little bit lost. And I talk about that video in the family of graphs, or the parent graphs. It's where I tell students to draw a picture of a straight line here, and I tell you to draw a parabola here, and I tell you to draw a cubic function here, and I tell you to draw a fourth quartic function, which it looks like a squared off U, and I think I tell you to draw a radical function. I tell you to draw an absolute value. I tell you to draw a, hold on a second, a rational function, and then a rational 1 over x squared. And I tell you that, and I go into all of that with the vertical and horizontal shifts. So I hope that'll work out for you, and I hope you'll be able to get through some more problems. Keep sending them, and I'll keep going over them. Capiche? Capiche? I'm not even Italian. All right, let me see. How do I get back? Let's see. Out of this. And that takes care of all the questions that were sent to me today, I think. But let me look and make sure, because I don't want to miss any. Let's see, what is this one? Okay, we did that one. We did that one. I don't think we did this one. This is 2.1. Okay, the reason this, okay, the reason is, all right, I'm going to go ahead and show you this one also because we didn't cover it. This is 2.1, number 1. It's a video type problem, which shows a video. And I'm going to see what the questions are asking, and then I'll just do it on the whiteboard. Okay, determine the intervals of functions decreasing, determine the intervals where function is constant, domain, range. Okay, it's asking the general information. All right, here we go. And I hope I can do this without the board messing up, but I'll go ahead and finish this one too. Domain. Okay, first thing you say is what's here and what's here. If you see arrows on the end of it as far as the x values, you're talking about all real numbers. So your domain is all real numbers, or negative infinity to positive infinity. Range. Range, you're gonna be restricted on. No, you're not gonna be restricted because you have these. Okay, that means you're gonna keep on going. So this one's gonna keep on going that way, and this one's gonna keep on going this way. So that means that all values of y will be used. So your range is from negative infinity to positive infinity, or all real numbers. Range, all reals, or negative infinity to positive infinity, and that is your y values. Remember, range is y. Okay, now we get out our plane. Let me get the plane out. The plane, the plane. There's our plane, and I'll bring it over here. Really, I'm sorry, but Mr. Board don't want to cooperate today, so I need to erase this, and I need to put it under the other thing so I can there. I know it looks like a shoe again, but I'm limited to what I can do with this. All right, so here we go. We start negative infinity because of the arrowhead. Now, what is this plane doing? It's increasing, Hubert. Yes, it's increasing to -1. And then it's decreasing to what? +1. And then it's increasing to infinity. So, here we go. It's increasing. I'm getting so sick of hitting this button 2 or 3 times. It's increasing from negative infinity to -1. Now, I'll go ahead and interject something here. It gets a parenthesis because, and this is a discussion that goes on with math teachers and students and math teachers and math teachers. People say, well, why would a bracket go here? Well, just think of Michael Jordan jumping from the top of the key and then coming down and dunking, let's say the basket's right here. And he dunks it and he comes on down and hits the floor. At this point right here, technically Michael Jordan is flying because he's neither going up or what? He's neither going down. So if you're neither going up or going down, what direction are you doing? You're flying, basically, for a millisecond. So that's why you don't get a bracket on that 1. Okay, that's why. Now, where is it decreasing? It's decreasing from 1 to what? I'm at -1 to +1. That's decreasing. And then increasing from what? From 1 to infinity. So the question that's most asked here is, why don't we have brackets on the 1s? And that's why. Because of that millisecond right here that you actually are flying, that's where it comes from. All right? Now, if there was a dot here, like a closed circle, then it would be a totally different problem and you would use brackets. And that's how you do that problem. All right. I will load this onto the Math 110 virtual office hours thing on YouTube. And as soon as oh my gosh, I need to reboot this computer. This board is just unbelievably aggravating today. It's those Russians, that's what it is. Okay, so I am closing this down. And I'll go and hit the, y'all have to excuse me, I'm trying to do everything